Okay, so press pause, see if you can do this one, and come back if you need. And here we go. So you've had a bit of a read. Here's you. Here's the plane flying away from you. It's flying at a speed, and you first see it at an angle of elevation of 45 degrees. It is measured as 20 metres away from you. You're pretty good at working out how far things are away. And it's moving at 10 root 2 metres per second that way. And you, so clearly that's 135 degrees. Let's just clean that 45 up. And you want to work out in 6 seconds' time, when it's here, how fast is it moving away from you? Not its speed horizontally, but how fast is that green line growing after 6 seconds? T equals 6. Let's put some letters on this. I'm going to go, so that length just there is going to be F. That's where it's flying, and I'll label the green A. That's the amount that it's getting away from you at. It doesn't really matter what letters you use anything you like, but we know df dt is its speed, which is 10 root 2. We want to find dA dt, so we need a chain rule. The other letter we've got is F, so there has to be a dF there and a dF there. So this is our missing piece. So we need to look at this triangle and get the relationship between A and F, and then get a dA dF. Okay, we can see that it's a non-right angle triangle, so it has to be either the sine rule or cosine rule. And clearly it's the cosine rule, minus 2 times 20 times f times cos 135. Now cos 135, 1 root 2, because it's a 45 degree triangle, and it's a big angle, so it's minus root 2. We want to rationalise the denominator, so it's going to be root 2 on 2. That 2 and that 40 will cancel, and we'll get, I guess I can just write it out. Put the number at the end. That 2 and that 40 become 20, so it's going to be, and the two negatives become a positive, so it's plus 20 root 2 f. That is extremely messy, but I'm sure you can press pause and work that out. I'll uncover that. Cos 135. Anyway, so here's our relationship between A and F, and we need a dA dF. So clearly, look, if you wanted to, you could go A equals a big square root and then differentiate that, but we're big boys and girls now, aren't we? So we can do implicit differentiation. F plus 20 root 2. So dA dx will be, it's not dx, it's dA dF. F plus 10 root 2 on A. Just get rid of that 2 there. Okay. So that is that. So we now get our dA dt is f plus 10 root 2 times df dt which is this 10 root 2. That's how fast it's flying. Right, we're still yet to get to this 14, so I need an F and an A to go in that thing there. I'm going to come back to this diagram. I need the length of F and the length of A. So this plane is flying at 10 root 2 meters per second, and it's 6 seconds later. So 6 times 10 root 2 is 60 root 2. So F as a distance is 60 root 2. And then we're going to go back into our cosine rule. We're going to put that F in there. And you're just going to use a calculator, I guess. Oh, okay. A squared equals F squared. So 6 sixes are 36, 2 zeros times 2, plus 20 root 2 times 60 root 2, plus 400. 2 sixes are 12, 2 zeros times 2, plus 400, so that's 2800, and 7200 is 10,000. So what's A? A equals 100. Look, that's a bit nasty for a test. I wouldn't do that to you, but maybe those external people would. So A is 100. So it's 60 root 2 plus 10 root 2 on 100 plus 10 root 2 times 10 root 2. 70 root 2 on 100 plus times 10 root 2. 7 times root 2 times root 2 is 7 times 2, which is 14. Okay, look, yes, as I said, I wouldn't do that to you in a test, but, you know, you should be able to do that without a calculator. It's a little bit time consuming for a test, but it's way good practice, and that's a fun question. Have fun with it.